Hello, and today we're going to talk about 7-10 fractional equations and extraneous solutions. Okay, this is really similar to when you were adding or subtracting rational expressions. Okay, so here we're subtracting, here we're adding, here we're adding. The difference is that now we have an equation. So this is the keyword equations. Equation means there's an equal sign. We have it equal to something. In the previous section, we just were adding or subtracting, and we were taking that expression and simplifying it. Okay, but now we have an equation, so we're actually going to solve for x. So there's an additional step here. We have to make sure that our solutions actually work. Okay, so I'm going to give you a method that works for all of these. If you look at this first problem, your first thought might be I have a fraction equal to another fraction. Equals in the middle, that's when you can cross multiply. And yes, you can do that. Okay? The problem is that method doesn't work here. And there's a way you could do it. You could combine the first two and then cross multiply. I'm going to give you a way that's a little easier. Okay, it's just kind of neat. So the first step is going to be similar to when we're adding and subtracting rational expressions. First step was to find the least common multiple of your denominators. In this case, and we look at both sides of the equation. We have an x minus 6 and an x minus 4. So our least common multiple is going to be x minus 6 and x minus 4. Okay? The next step is different. And the next step is what makes this method really nice. Okay? So we're going to take the left side of the equation, x over x minus 6, equal to 1 over x minus 4. Okay? I left room here because we're going to take both sides of the equation and multiply by this thing. Okay? So on the left side of the equation, when you multiply by something, it really goes to the numerator. We're not multiplying top and bottom. We're not multiplying clever from a 1. We have an equation. So we have a new tactic that we can do. We can multiply both sides of the equation, really just on top, by the least common multiple, x minus 6, x minus 4. So on the right side, x minus 6, x minus 4. Okay, the nice thing about this is maybe you all love working with fractions, but I think it's kind of nice if we can get rid of the fractions right at the beginning. Okay, and now we can. Since we multiplied both sides of the equation by the least common multiple, we know we're going to be able to knock out all of our denominators in every term. The x over 6 cancels with x minus 6 cancels with x minus 6. X minus 4 cancels with x minus 4. What's left is x times x minus 4 is equal to x minus 6. Ta-da! No denominators. So now we simply solve this equation, which is going to turn out to be a quadratic. So we're going to distribute x squared minus 4x equals x minus 6. So come over here, subtract the x over here, and add 6 to both sides. So x squared, we subtract x from both sides, we get minus 5x. We add 6 to both sides, I'm going to get plus 6, equal to 0. Okay? And then we can factor, multiply to 6, add to negative 5. So an x and an x, so 6 and 1. We want minus 6 and plus 1, because x squared minus 6x plus 1x minus 6. So our solution to the equation is going to be x equals negative 6 and x equals, negative 1. Negative 1 here and positive 6 here. Okay. Now, we have to check for extraneous solutions. And this is usually a pretty quick step. All we need to do is make sure we don't have to plug them back into the original, make sure they work. What we have to do is make sure that none of these will make any of our denominators 0. Because if this made let's say positive 4 was one of our solutions. Well, we'd see we plug in 4, we get something undefined. That would be extraneous. Okay? But negative 1 is fine. Negative 1 doesn't make this denominator 0. Negative 1 doesn't make this denominator 0. Check 6. Ooh, 6 is a problem. 6 makes this denominator 0. 6 is extraneous. Okay, so our only solution is x equals negative 1. Okay, and I want to see that you actually solved for both, and then you cross this out. Okay, so don't erase it really hard so I can't see it. It's good to be able to see that you found these two solutions and you notice this one is extraneous. You can even write 6 is extraneous. Okay. Now let's do one more example, maybe two more examples. This one, first step, before we even do the least common multiple thing, we're going to factor everything that can factor. So I've got x over x minus 3 plus, notice I'm leaving space, 2x, space at the beginning, let's do, plus 2x over x plus 3. I like to put these in parentheses. Equals 18 over, and that factors into x minus 3, x plus 3. Our least common multiple is, we have an x minus 3, we have an x plus 3, we have an x minus 3, x plus 3. So our least common multiple is going to be x minus 3, x plus 3. So now I'm going to take that least common multiple, I'm going to multiply it by both sides of the equation. So it gets distributed to this term and this term. So x times x minus 3x plus 3 for 2x, x minus 3, x plus 3. The 18, x minus 3, x plus 3. Okay, let's do our canceling. X minus 3's cancel here. X plus 3's cancel here. Here the x minus 3's and the x plus 3's cancel. So we get x times x plus 3 equals 2x times x minus 3 equal to 18. Okay. Now we solve, distribute. Oh, that should be a plus. Sorry, typo. Bring down that plus. That's an equals. Okay. So x squared plus 3x plus 2x squared minus 6x equals 18. Combine like terms, x squared and 2x squared, 3x squared plus 3x minus 6x minus 3x. And then I'll subtract 18 from both sides, so minus 18 equal to 0. Okay, I'm going to factor 3 out of each term. X squared minus x minus 6 equal to 0. So 3 times x minus 3, x plus 2. So x is going to equal positive 3, negative 2. Now, do either of these make any of our denominators 0? Check the factored form. So negative 2 is fine, but 3 is a problem. 3 would make this denominator 0, so we cross that out. Our solution is x equals negative 2. Okay, so that's really it. So go ahead and work on the 710 delta math. If you want to stick around for one more example, if you need to see it one more time, I'll do one more example, okay? Otherwise, go ahead and get started on the delta math, okay? Let's pick, well, this one's a quick one. This we could do a couple different methods. If you want, you could just subtract the 5 over here, and now you've got something a little bit easier. But let's do our method. Least common multiple would just be, so these are not, you don't even have denominators. We can think of them as 1. So it's going to be x plus 1. So we're going to multiply everything by x plus 1. 5 times x plus 1 minus 4 over x plus 1. That gets multiplied by x plus 1 equals 6, and that gets multiplied by x plus 1. So we're multiplying both sides of the equation by this. It distributes to every single term. Okay. So here those cancel. 5x plus 5 minus 4 equals 6x plus 6. I'm going to subtract 5x to both sides, so I have a positive x over here. Over here, 5 minus 4 is 1. Subtract the 6, I get negative 5, and x equals negative 5. That works. That doesn't make any denominator 0. Okay. And the other three are going to be similar to this one. Interesting. Actually, let's look at, let's do this one down here, number 3. With this one. Okay, they're all kind of similar. We'll do one more. So b over b plus 3 minus b over b minus 2 equals 10 over, and that factors into b plus 3, b minus 2. Okay, it works out nicely that our least common multiple. It's going to be b plus 2, b minus 3. So b plus 2, b minus 3, b plus 2, b minus 3, b plus 2, b minus 3. Fun part, knock out those denominators. B plus 2, b minus 3. Oh, that doesn't quite work out, does it? Let's see. B plus 2, b minus 3. Oh, those aren't the same. Let's make sure. Did I do that right? That factors into b plus 2, b plus 3, b minus 2. Okay, so these should be b plus 3, b minus 2. That factors into b plus 3, b minus 2. So this should be b plus 3, b minus 2, b plus 3, b minus 2, b plus 3, b minus 2. So the b plus 3's cancel. I'm left with b times b minus 2 minus, and the b minus 2's cancel. B times b plus 3 equals, and that all cancels, so we get 10. Okay, so we get b squared minus 2b minus b squared minus 3b equals 10. So b squared minus b squared, that goes away. I get negative 5b equals 10. Divide by negative 5. I get b equals negative 2. And that actually doesn't make any of our denominators 0. So that works. Okay. I feel like something's a little goofy. If you want, you can always just plug it into the entire thing and make sure it makes the equation, make sure this actually works. So we'd have negative 2, if b is negative 2, negative 2 over negative 2 plus 3 over, so over 1 minus negative 2 over negative 2 minus 2, negative 4 equals 10 over, let's plug this into the, plug that into the factor, no, we'll just, that's going to be 10 over, okay, this thing. That's b squared is 4 minus 2, so 2 minus 6, so negative 4. So that's negative 2 plus, oh, that's going to be minus. There's 3 minuses there, so that's going to be minus 1/2. So that gives you negative 2.5. It's a minus there. Equals negative 5/2. And that works, okay? You don't have to check that. I just thought I'd check it because I kind of messed that part up. And it works, okay? And it doesn't make any of your denominators 0. Okay? Thank you for watching. I hope that was helpful. And see you all next time.